I believe. I could be mistaken, but we'd like to have this as a opportunity for the Foursquare team to review afterwards, just in case. Let's see, Takoya, I know that you, I'm still looking at your resume. So you came in second on Common Lit and fourth on NBE. Yeah, we have plenty of first place winners over and over again. So I know this isn't your first time doing this. But let me be once again to congratulate you on a great success and victory in the Foursquare competition. My name is Addison, as you may know. You often see me in the competition forums, whether that be a good thing or a bad thing. I'm the main contact on the Kaggle team. I'll let Zisas and Nadine introduce themselves here shortly. But the way this call generally goes, after the Foursquare team has had a chance to introduce themselves, we will let you share your screen, share your presentation, and walk through it for the Foursquare team. They may ask some questions as they go or ask them at the end. We'll also want to have any questions that you have for us and be able to answer those. Once that is done, this is, I believe, the last call we have scheduled. Hey, Chris. This is the last call we have scheduled, and so we will be paying out the prizes here shortly. But we want to make sure that if you have any questions, the Foursquare team has any questions, this is a great time to do so. But before we dive in, any questions from anybody here on the call? All right, well, in hearing none, I'm going to fade into the background here. Zisas, I'll let you take it away for the Foursquare folks.
Sounds good. Thanks, Addison. Thanks for being here, and congratulations on the competition. I'm Zisas. I work with Foursquare for the last almost 5 years as a data scientist, machine learning engineer at the beginning, and recently as engineering manager of a team that works on problems similar to the one that we posted in this competition. So trying to extract knowledge of places that Foursquare has on their database and enrich these attributes. That's for me. Chris, you want to introduce yourself?
Yeah, hey, I'm Chris. I worked at Foursquare going on 6 years in a month or two. I'm just a software engineer, but I work under Zisas on his team, and I have some experience with this problem on maintaining our version that does this in production. But less on the data side, just keeping it running, but or on the ML side. But yeah, that's me. Yeah, that's it. Pass it on. I guess Saurav didn't make it in time. Do we? I guess Nadine or no?
Hi, yeah, I'm Nadine. I'm on the marketing side, working with Ariel for B2B marketing. We're collaborating with Kaggle on the competition, and we're really excited for your participation. Congratulations on this first. It's really excited for your presentation.
All right, well, with that, we will hand it over to you. If you, I'm not sure which of you will be presenting. We'll let you begin your presentation, share your screen, and introduce yourselves, and we'll get started from there. All right, we can see your screen.
Sorry, my mic is troubling. Can you see my screen?
Yes, we can.
Okay. So let me start. And also, sorry, my team is to be honest, we are not good at English. So if you have question, I'm happy to use chat comment. We can understand more precise. Yeah. Sorry. Yes, and yes, I will explain our team's solution by this presentation. Okay. Sure. Yes. First, I will introduce my team. Introduction. Yes. Our team is name is waiwai. Yeah. Our team is the revenge team of past competition Google Brain Venture Prediction. In this competition, we will join as YY team. And so this competition we will try. So this competition's team name is DYY. Yes, and also the result is public and private. Almost both of them is first place. And also you calculate the scoring part with no duplicate data. In that data, we are fourth place. Yes. Okay. And yes, we will show our overall pipeline. Yes, we use mainly force models pipeline and with finally post process. This is duplicate part. So mainly if we don't think the Turing test duplicate, we use mainly force part model we use. Yes. And I will explain the details of this each part. Yes. And also we calculate cross validation score, and we use twofold training in the our models validation. And also in submit model, we use all data. So not two. If we use only twofold, the data is half. So yes, we use all data in the model. Yes. Okay. So let's start all of the detail of pipeline. Yes. First, we use candidate generate. Yes. Candidate generate, we use two part. One is location based, and second one is name base. Yes. And we select 100 candidates per each ID. And yes. So about location, we use latitude and longitude neighbor. Yes, this is, I think, it's very simple. And also we use name neighbor using by BART embedding and KNN of QML we use, and cosine similarity of name embedding we use. Yes, and also, sorry, I forget to one explain. So we use those neighbor grouping by country. So yes, I think if we just use only name neighbor, there is it may be happen to very different country, but we use firstly group by country. So in same countries, we use same similar name. This name neighbor part. Yes.
Can
Okay.
I ask a quick question?
Yeah. Okay.
For step number 2 in BERT, before you send the text as input, do you do any pre-processing, any changes, or do you send the name as it is?
Mainly we use original. これさん、
The original, right?
高橋さん、なんかありましたっけ？覚えてます。
特にこれ何もしてなくて、
そうですよ。
ね。はい。
Yeah, I think, we use very simple model, and of course, this is multilingual, but yeah.
Thanks.
but we use no special pre-processing.
Sounds good. Thanks.
Okay. Okay, so me explain first stage model. Yeah, and first stage model we use right GBM model with few features. Because in this part there are many candidates or pairs, so we have to save the memory. So we create a raw memory model. So so for example, there is 60 600,000 record and 100 candidates. There is 60 million records. It's very big, and if we create many features, it is difficult to run submit model. So because this is code competition, so our memory is just our memory is only 16 gigabyte. It's difficult to big model. So yes, we select very few features, and the features is the something or the name zero distance. This is the name. Many team use it, I think. So zero distance of name columns, or distance ranking of the distance ranking, or other. There is a very simple feature we use. And from this feature, we select top 20 candidates per ID in each model. So we select from top 100 to top 20. We select. Yes, and this is one good point for our team. So mainly the public notebook, mainly just using from the candidate generate, they select only top 20 ID. So compared to it, first we add this first stage model. The score is very improved. Yes.
Can you explain a little what the distance near ranking feature is? Is it 1 to 100 values, or is it something different?
Yes. So so there is one from one is most nearest part, most nearest path, most nearest point, and 100 is more farthest. Yes.
Gotcha. And are there other features there besides the gyro distance and the distance near ranking?
And yes, I think we used 何個ぐらいだっけな 5 or 6 features. Wait a minute. 何個ぐらいでしたっけ？
ですね。日本語であれなんですけど、位置情報の方が特徴量8個使っていて、ネームの方が1、2、3、4。両方8ですね。
両方8個ですね。So we use 8 features. So we use a total 16 feature and 8 feature of location and 8 feature of name part. Yes, and
okay. So you do not use any information on the other attributes, address, phone, category, they are not included here, right?
Yeah, wait a minute. 名前とか名前以外使ってましたっけ？本。
ですね、これ、位置情報の方は、カテゴリーを使っていて、ネームの方はカテゴリー使ってないんで、一応カテゴリーは使ってます。
Okay. So we just use category columns, and edit distance. We use category and name and latitude and longitude. We use this part.
Great, thanks.
Okay, thank you. Okay, so we will explain next phase. Yes. And the second stage model, yes, we select from before the second stage, we select 14 candidates per ID because this part top 20, and this part top 20, and the summarize, and there is 40 candidates. Yes. And in that timing, we use write GBM with which features. So yeah, we use many features in that timing. Yes, about 120 features. Yes, this timing. And yeah, this model is more accurate than first stage model. Yes. And in this model, after we predict all data, and we use threshold to threshold 0.01 for next stage. We want to limit the number of candidates. Because we use BART model in third stage, but BART model has takes a lot of time of inference. So yeah, we select before using BART. Yes, in this part. Okay. And the features summary. This is, I think it's very simple features and not special feature. But character similarity features like Levenstein, Dizaro, Winker. And in this stage, we use many columns, not only name and category, and just for example, address or phone, or we use many columns. Yes. And also the character similarity statics, maximum and the minimum and average, using ID as key, so group by ID, and name zero mean, or name zero max value, or the ratio of those statics. So like so the compared to the maximum value of the that I record feature. Yes. And also we use Euclidean distance using latitude and longitude. And by the way, we try to other distance feature like the geo distance feature, Havans or something. We tried, but there is no difference of the result. So we use just simple Euclidean distance in the location. Yes, and also embedding of name with SVD for dimensionally reduction. Yes, so the embedding means the BART embeddings. Yes, BART embeddings SVD we use. Yes. Okay, this is our feature summarize. Yes. Okay. We proceed next phase. Yes, and the third stage model, yeah, we in the third stage, there is many limited record. So by first stage and second stage. So in this timing, we can use rich model. Yes, and first GBDT model, and this is cat boost and same feature of with second stage, and also we use BART family model. We use two BART family model. One is XLM Roberta Rush, and second model is MDBADA V3 base. Yeah, both of them is multilingual model. Yes. And the input of this BART is we just use concatenate multiple columns. So name plus category plus address plus city plus state we use in those BART families input. Yes. And yes, in MDBATA, we train with FGM and EMA. This is recently popular technique in Kaggle. This is adversarial training technique. Yes, AWP is adversary weight fluctuation. Yeah, and those is very similar, but yeah. Sorry. FGM is very adversarial training, and EMA is general technique in, I think, in deep learning. Yes. Yeah. And and we will and this FGM is improved the model of MDBATA. Yes. Okay. And after that, third stage, we use weight average or second stage right GBM, and third stage three model. So we use four model in the weight average. Okay. Yeah, and I think gradient boost and but ensemble is very good result. Because just only one model, the score is not good. So yes, I think the blending of those different model is one key for good score, I think. Okay, and we will explain force postpress. Yes, this force postpress is maybe it's just original part for our theme. Yes, force. I think in the result of prediction result, we have some score. So, for example, IDA and IDB's pair, the score is 0.8, and IDB and IDC, the score is 0.9, IDA, IDC, 0.4. And if we set the threshold is 0.5, IDA is just match with IDB. Just only we select this part in IDA, but IDA and IDB and IDB and IDC is very predict high score. So in that case, IDA and IDB and IDC is connected indirectly. So we add IDC in IDA matches. Yes, maybe this is used as a team also. Yes, but I think this is one point. And the second point is above post process after post process of above this post process post processing. There is some we increase false negative. I think, but this part will increase false positive because this post processing is increasing the pair. Because this is so I think this is record is improved, but I think precision is become worse. So in new pair, from those post process new pair, we repredict with XML raw data, which is same or not. And if it is low prediction score, we remove this matches pair. Yes, so this is our team's false positive. We can decrease false positive in all data. This is one point of the post processing part. And okay, and finally, this is for leakage process. And how do you find the leakage in our team? We have some hints of this competition. When we increase the BAT epoch, the score, the public leaderboard is very improved. So especially, for example, in 2-4 training, the best epoch is just 3, but in all data training, 10 epoch model is better than 3 or 5 epoch model. And we think this may be overfit model with 10 epoch model. So when after that we try no dropout model. I think no dropout model has tendency of overfit. So we try this model, and also this model is the score is improved. So those two is the I think overfitting indicators. And yes, so we suspicious the some leakage. And also the top team score is in leaderboard is very higher than ours. Yes, and we never thought the score could go up this high. Yeah, so this is too high. So also this is one clue of the leakage. And also the LB leaderboard score is higher than cross-validation score. Yes, this is also some hint. So yes, for these clues, we conclude that leakage must be occurring. And the leakage part is very simple. And yes, we merge train and test data by name and ladron data. Yes. Yes, and I think this part is I think yeah. We don't have to explain that in detail, but yes, we use two parts. So if we can match train and test data, remove we can false positive data from train test data. Yes, and the magic trains result is very big. So we compared the model, a simple model without magic train is 0.9, and this is the not I think final model, but yes, and after that we just create all true pair from train test data. The score is 0.943. And also we use remove the false positive part. After that, our score is 0.971. Yeah, yes. Yes, so this is, and also the final submission we use 1+2 post processing and 1 to 3 post processing. We choose the at final submission. Okay, and the final version of the score. Yes, the overfit version of the model, the score is right weak. And yes, so without train merge, our team 0.946, and with train merge 0.976. Yes, and non-overfit version 1. So we create two model because we think the data is has leakage, but if there is just only public data, it's risky. So that we not only overfit model, we use just no overfit model. So this model is very overfit because no dropout and 8 epoch. So this is good in public score, but I don't know in the CV score. And this model is no overfit model. So I think this model is good in no duplicate data between train and test. Yes, and we use this model and the post-processing. I think the post-processing part, if there is no leakage in private test set, it's no effect because we cannot merge in this part, and it's no effect in any case. So we use all this post process with both model. Yes, and yeah, this is almost same. Yes, of this non-overfit part. Yeah. So what I want to say is we use overfit model and non-overfit model we prepared. Yes. And other tips for this competition, we use forest inference of QML library for like GBM inference. Yeah, it's very fast in GPU environment. Yeah, it's good for code competition. Yes, and yes, and this is I said in the first process is per country in inference. Yes, this is very efficient and fast in this competition. Yes, and also we use NumPy array for future storing instead of pandas. Yeah, pandas has needs many more memory, so we use NumPy array for future engineering part and using inference part. Yes. Of course, the invert part we convert to PyTorch tensor, but mainly we have data as NumPy array. Okay, and the code inference is this. Yes, thank you for listening. Yeah, this is our solution summarize. Okay.
Thanks for that. Thanks for walking us through. How long did it take for training the models?
Models, I think it's different of part. I think RightGB model is not big. I think within one hour. But I think Roberta or MD Barata is 1 epoch takes 3 hours in A100 instance. So 10 epoch model takes 30 hours, and 4 epoch model takes 12 hours. Yes, so I think total part is more than I think 15 or 40 hours.
That on the GPU, right?
Yes, we use GPU in BART model, but in local part, the gradient boosting, we don't use GPU. Yeah, it's CPU instance we use.
All right, and just curious, how long were you following the competition? Did you start from the beginning of competition or joined later?
I think before the middle, so we start for example, I think before June, so I think we joined in May. This competition, yes.
So somewhere in the middle. Nice. Congrats again. That's all I had. Chris, do you have any other questions?
I don't think I do. I think I'm good. Very interesting.
Do you have any questions for us?
Okay. So from me, one question. So I think this competition, the data is synthetic data. We use synthetic data or the host, and the data is very near from the real data, or there is some difference of the real data. I want to know the difference point of the real and synthetic data.
Yeah, several of those are inspired from real places, and we added some noise in the different attributes. We added some noise in some of them in the name, in the address, in the coordinates, latitude, longitude, to make it more challenging, and also to simulate what real bad data look like.
Yeah. So I think real data is also has very noise, and yeah. And I think the simulation noise is has some tendency. So like I think location noise is very simple, but name noise is, I think it's difficult to simulate the real data. So this is some difference from real data noise. So for example, if we add noise in simulation data, change the character or remove the character or add other character, we can do. But the real data also has some tendency of the noise, I think. Is there any difference?
The added noise in the name were some typos, or it could be some how do you say, some added words in between, some stop words like and some prepositions in English names, or some endings in the end of the word. Usually not semantic differences, or it might be some words like incorporated for companies, etc. For latitude and longitude, it might have been noise simulating the changes that you could see in the coordinates if you were getting a GPS signal of higher or low accuracy that can throw the GPS several meters apart. And in some cases, more extreme than that.
Okay, I see. Thank you.
Mm-hmm. Nadine, do you have any comments or questions as well?
Yeah, thank you so much for the presentation. That was really great, and thank you for participating. Just on the marketing side, we were wondering if you would be willing to be featured in a webinar or a blog post from the Foursquare side, and just let me know if you are.
It may have been a little bit difficult to hear Nadine. She's asking if you'd be willing to be in a blog or a webinar on the website.
I'm so sorry. I think my signal is really bad.
You'd be. So you said this winner's call will make to will become to blog. Is it right? Or for blog we have to another session. Okay.
No, I'll write an article about you, if that's okay, and mention about your presentation and your work in this competition.
Okay, that's no problem, I think.
Okay, sounds good. I'll email you soon.
Okay.
Okay, that's all the questions we have. Thank you everybody for your time. Best of luck in the next Kaggle competition, and we'll be paying you out here shortly.
Okay.
Thank you.
And
Okay.
congratulations again.
Thank you.
Bye.